Hello guys, today we're gonna talk about AP Calculus notes, and this is gonna be on the topic of area between two curves. So as you can see, whenever we're dealing with integration, we're looking for an exact area between the curves about the x-axis. So right now we actually have two different let's say we have two different functions, f of x and the other one is g of x, and assume that f of x is on the top of g of x. Then in order to find out area between two curves, what we will do is we want to find out where they're intersecting, point A and point B, and from that we're going to use the top minus bottom, so top graph minus bottom graph, hence f of x minus g of x, and then we're going to take integration of the whole thing. So let's just do a problem really quickly. So right here we have two different functions. So right away, what I want to do is actually let's go ahead and graph something that that will represent these. So I have TI-84 right here. So let's just graph this. Oops, it's not working. Oh, I went to sleep. So let's do this. Okay, we have x plus 3 plus 3, and then the other one is x squared plus 1. Well, actually, without using a graph, we can actually easily sketch this thing, because we know that, well, x plus 3 is basically a straight line that's going to go through that point, that point, that point. So it's going to be a straight, oh, my apology, straight line that goes through those 2 points, these points. And x squared plus 1, we know it's going to be a parabola that goes through that. And then if we plug in 1, we have 2 right here. And then 2 here, we have 5 right here. Approximately. So that's my graph look like. So as you can see, our target area will be right in the middle right here. So without actually using the graph, we can actually find out this one just by using calculation. So we have f of x over g of x. So f of x, since f of x is this one, g of x is this one. Well, actually, change the color. Let me do g of x as red. So we can say f of x minus g of x integration would find out. But furthermore, we actually need to find out what these 2 points are. These 2 points are very, very important points. Well, what to do when we try to find out these 2 points is we actually set these two functions equal to each other. So x plus 3 equals to x squared plus 1. So by doing that, we can say, well, we can do a few maneuver. I can move everything to this side, minus 2. And then therefore I can, well, factor minus 2 x plus 1. Okay? And as you can see right here, this is what we have. And we can say x will equal to 2 and x equals negative 1. So we know, let's say this is B, this is A. A would be negative 1, B therefore would equal to 2. Okay, so from that we can use our formula that we have right here at the very, very beginning. Okay, our A is negative 1, so let's do that. A is negative 1. Oh, sorry, wrong sign. A is negative 1, B is 2, and f of x would be this one. X plus 3 minus g of x, which will be this one. X squared plus 1. So x plus 3 minus x squared plus 1 dx. So now when we do the integration right here, oh, my apology, then it will be easier if we just take everything out. Plus 3 minus x squared minus 1 dx. Well, this one's fairly easy integration to do. We can separate them into different components, and therefore we will see the integration of this would be negative x to the third power divided by 3 plus x squared divided by 2 plus 2 x, and everything would be in that bracket. So then we can further calculate these by plugging in 2 in all of them. So this one will be 8 over 3 plus 4 over 2 plus 4 minus, let me put it in parentheses so it's easier to see, minus positive 1 over 3 plus right here is 1 over 2 minus 2. Okay, so sorry, it's like that. Okay, so we can further simplify these by stating, actually let me move the calculator really quick. Okay, let's say, well, change the sign. Plus 2 plus 4 minus 1/3 minus 1/2 plus 2. Okay, so this is beautiful, something works out nicely. So as we can see right here, we have minus 9 over between those two. Well, these three together, the one that I boxed, well, these three together add up to 8, and then just minus 1/2. Well, we also know that the first term becomes negative 3 plus 8 minus 1/2. So our final answer would be 4 and 1/2. That's how we know the area between the curve. And again, this will be unit square since it's looking for area. So that's the first question. Very easy because it's a very simple question. However, as you can see, I have my calculator on the right hand side. Obviously, later we'll be doing something a little bit more challenging. So let's get to it. So right now we have this one. This is the second question that says we are going to deal with slightly more difficult question. So in this case, I need to figure out which one is which one. And on top of that, let me just make sure you guys know how to use calculator. I have used calculator right here. Oh, calculator is sleeping. Okay, let me clear this. Let me graph both of the equation, and then just so this way we can see which one is on top, which one is on bottom. And then furthermore, I'm gonna graph it right here as well to see how it looks like. So I have a y. This is already y, so I tap y equal, and then that's how we have on the screen. So we're gonna go ahead and say square root, which is right here in a blue. So since it's blue, that, and then square x. Close the parenthesis and push enter. Second one, it's negative 1/4. So negative, this is negative button, this is not minus, which is very different from negative. 1 divided by 4, and then you have a variable x, and now we're done. So that's only two things. Well, this one, the calculator actually, we're not going to go through graphing x equals 4, because x equals 4, as you guys know, it's a vertical line. So later on, I would just draw the vertical line right here. So now, since we are done, let me go ahead and check my window, make sure it is the same thing as my graph. So let me go for negative 2, that's a minimum for x. You can push enter or you push it down. 6, that's my maximum for x. 1 scale, and then this one will be negative 2, and then the next one will be just 4. And the scale, everything remains the same. Now I can go ahead and graph. As you can see, I have first graph going this direction, the other one goes down. So let me copy the same thing. Okay, as you can see, let me change the color so we can see. This one is gonna be red, and let's do blue. This one is gonna be blue. So red one starting from what, because it's a radical. So we actually don't have any negative numbers. So we have something like this. And then for the blue one, because the blue one is a straight line, it's a linear function, and it has a slope, negative slope, so it's actually gonna go almost like that. Well, but as you can see, we don't have an enclosed area. But this is when our beautiful highlighter comes in play. Sorry, that our third boundary tells us. Let me use, I don't know, black. X equals 4. So that is actually my fourth boundary that's supposed to be drawn, but it wasn't drawn on the calculator. So this is actually the area I'm looking for, right here. Okay, so that's the area we're looking for. And as you can see, well, I need two boundary. Well, I have my 4 as my upper boundary, so this one also equals B. Now I need to find A. Well, A is just conveniently right there, and if you don't know by looking at graph where the A is, you can always set these two equations equal to each other. Okay, and you will still get 0. So let's write down this integration really quick. A and B. It will be square root of x minus -1/4 x everything dx. Okay, so this is what we have right here. And as you can see, a earlier we said is going to be 0, x is going to be b. So we actually need to, like, whenever you're doing anything that's on the calculator, you have to write it down, or if you assume people know, you need to actually write down the value. So that's also write down a equals to 0. And then since we write down here b equals that, so we can rewrite this entire thing. So a equals to 0, b equals to, I forgot, 4. Getting O. So now we have square root of x, let's change it into 1/2, minus negative, so plus 1/4 x dx. Again, this is an easy integration, so we can just quickly, let me do it on the left hand side, so this way everybody can see. Integration 0 to 4. Oh, actually, I can just integrate. I'm going to go ahead and integrate the whole thing. So this one, R1 divided by whole thing, it will be 3/2 plus x squared divided by 2, so it's going to be x squared divided by 2. Everything is going to be 0. Okay, now we can also simplify a little bit. X squared 3/2. Oops, that is an ugly 3. Let me redo that. 2, and then 3 on the bottom, plus x squared 8. Again, 4 and 0. Okay, so now let me plug in numbers. So I know square root of 4 equals 2. So 2 to the third power equals 8. So 2 times 8 divided by 3 plus 4 times 4 is 16 divided by 8 equals 2 minus everything becomes 0, so minus 0. So 16 over 3 plus 2. I'm going to put everything as a fraction right here. So everything will be over 3. 6, which should be 22. So this way would be unit squared. So that's our second problem right here. That's how we do this kind of problem. Okay, so I'm gonna stop right here. I'm gonna do a part 2 and part 3 because yeah, I don't want the video to be too long. So I will see you guys in part 2. This is notes for AP Calculus and the subject of area between two curves.